do some more Roch ASMR rhyme here to either teach about biology, space, history, or just yap about my day. Or other random stuff, whatever I come up with at this point. Today, I will be trying to, at the best of my ability, teach you about the end of the universe, or how the universe will end. Or could. Who knows? Maybe our models could be wrong. Maybe something could change, a new fundamental discovery. But I'm going to start in the solar system. I already discussed in my first video about the sun eventually going supernova, eventually exhausting its critical resources it needs to be able to stay alive. I already explained that in detail. Short story: runs out of hydrogen starts fusing into helium, causes it to swell to about the orbit of Earth, possibly destroying Earth, most likely. And then it's out of there, like, melt away into forming a white dwarf. But before that happens, there's no things interesting that happen. Two big things that I know about. Saturn, after hundreds of millions of years, around 300 million per sure, will lose its rings. It will eventually lose them. They'll fall into the atmosphere of it. But the moons of Mars, for sure, Phobos and I forgot the other name. They, for sure, Phobos. There's just one, the inner one. I'm pretty sure it will fall so close it'll get into the tidal zone. The Roche limit. The Roche limit ground down into a nice ring, which is very nice. Of course, anyways. Now back to after the sun died, because we could be here for I think maybe 10 minutes, hopefully. I don't know. After this, more stars begin to die. After a star, I mean, it's relevant. It's going to happen eventually. But as they keep dying and dying, they don't return as much gas as they were given. So the birth rate of the universe for stars slowly goes down until eventually there are no new stars left. No new stars born, anyways. Now this will take like millions, if not like billions, up to like 500 to like a trillion. Like basically a long time before this happens. A long time. And when this happens, all that'll be left is possibly red dwarfs. I'm pretty sure most likely not. And dead stars, the remnants of them. Which is basically black holes, neutron stars, and white dwarfs. Those will be the only stars remaining, or celestial bodies, to say. After millions of years after that, they begin to cool. And cool, well, the black hole neutron star, no, I'm pretty sure neutron might, but take longer. White dwarfs begin to cool. But let's go back to our solar system. Let's go back to that. Alright. All of the planets will eventually decay. Well, they all matter eventually. With certain measurements we have, they all decay, but we'll get to that later. After more billions, trillions of years, there may be even new star formations because of brown dwarfs colliding. It's a possibility. It happened before. But we'd also have new kilonovas, they're called, when two neutron stars collide together. Pretty much imagine a supernova, but bigger, brighter, and beautiful. That I would know. I'll let you know. That is beautiful, bright, but also radioactive. Hell and back. So yeah. But as this keeps going, as neutron stars begin dying off, black holes begin growing bigger, because all the residual matter would probably, I'm pretty sure, would eventually fall into the center due to gravitational pull. Except for, I'm pretty sure it's dark matter. It's not dark matter. It's dark energy. I wasn't correct there. Dark energy holds it together. I think, oh no, it's dark matter. I don't. But I know dark energy is what causes the expansion of the universe. That's the main thing that happens. Dark energy, pretty much, energy there that causes space-time to go. Any listeners out there who's listening to my content, hi. But also it would basically keep growing. The universe keep growing and growing and growing. So yeah, until eventually it will grow so fast. It'll grow faster than the speed of light. And I've heard saying nothing will be faster than the speed of light. Maybe. But space-time itself can definitely be faster. I'm pretty sure it definitely can be. Oh. So that'll be in the future too. That happens before, like, alright, let's talk about a little group again. I'm chaotic. I'm all over the place. I apologize greatly, but I just love yapping about stuff like this. But if we keep going like this, eventually, in 5 billion years, the Milky Way and the Andromeda will collide and form Andromeda. Pretty sure it'll be an elliptical galaxy, so. Yeah. But also, all the other galaxies and stuff in that time, in that space, would collide. And because the expansion of the universe would expand at the faster speed of light, we would technically become our own universe. From our perspective, because we wouldn't see anything else, we wouldn't see any light, because that's what happens. Light's emitted from an object far away, and as time goes by, it moves closer and closer until it gets to your eye and sees the retina. That's what happens. That's how we can see distant galaxies, or back in time. That's how we saw the youngest part of the universe, the background radiation, because the light there is just reaching us now. I just think it's really cool. But, yeah. Moving on. We would also... Okay, I realize this is getting in the way. Let me put it down a little more. That seems way better. But yeah. But as more stars, as these stars begin to die, as the neutron stars, I'm pretty sure they die off to return to black dwarfs. Oh, I forgot to mention that. Eventually white dwarfs, those dead things become even deader. Even deader, I know. Who knew the dead bodies of stars can decompose, I guess. That happens later. That happens way later. The fact that the white dwarfs will eventually cool down so much they'll become a black dwarf. And black dwarfs, they dance, but also incredibly cold and not radioactive. Pretty much invisible. That's probably a nightmare. Any future civilizations over there. Just going in something like a cruiser of some kind, like a space cruiser, I don't know, whatever the use interstellar travel then suddenly you get immediately erased, spaghettified because of a black dwarf you cannot see, which is again 1,000,000 times denser than the sun. Them dense. They pretty dense, I'm not gonna lie. They're pretty dense. Sorry for looking around, I get distracted easily. Anyways, wait a second. What's that say? Wait, sorry, I'm very sorry. I had something come up. I'm very sorry. I'm gonna keep talking, alright. But when these black holes become black dwarfs, pretty sure neutron stars do too. And at this point, planets still exist, but barely any exist. And at this point, we're going to get to a point where it gets really theoretical. Well, not theoretical, but the one theory, it depends on everything. A single theory. Yeah, hopefully that helped me prevent looking at the screen so much. That would help. That could change everything. If atoms could decay, like, I'm not talking about decay into smaller atoms, like cause radiation, but I mean the actual subatomic particles themselves. The atom is of like the proton and neutron decaying. If those can actually fall apart, if they don't, way wild scenario that I'm gonna say now. But for the scenario, we're gonna say they do decay. Which in that case, life's cooked. Civilization's deep fried. We're all done. We're all done for. I should probably talk more like a whispery type tone. I'm sorry. I apologize very much really for that. If anyone's even watching this. Oh, there's one person who watched my videos. A lot. Wait, I gotta say thank you so much. I think they watch videos. I really hope they do. But again, don't worry. I'm up. I'll put my setup on correctly as soon as I can. Which probably won't be for like a year. So hang out then. You'll get top-notch videos. But yeah, I'm gonna keep yapping about the universe now. Because I love yapping about this. Okay, so if matter does decay like that, black dwarfs and planets will start to decay after a while. Their protons, their neutrons fading away into obscurity, replaced by radiation, and I'm pretty sure replaced by those two things. This happens slowly over time. Over trillions of years, I'm pretty sure. And at that point, would life not be able to exist anymore because the stuff we use to create the atoms and stuff would not be around anymore. At this point in the universe, only black holes exist. And there's some cool things come with that. Like zombie galaxies, where galaxies are only made with black holes, where we have a supermassive one at the center. But then, of course, we have the regular black holes around, like orbiting around it, like a galaxy. But I think it might be significantly smaller though. Like the smaller black holes would merge together, and they might merge into a black hole, making the black hole in the center even bigger. But at this point, they all will condense bigly. There are eventually black holes that are trillions, if not quadrillions, the mass of our sun. That would mean, I think, we have hypermassive black holes. I'm gonna call it gigamass black holes. Gigamass black holes. Oh yes, gigamass black holes. Very much good. But yeah, eventually these giants, after years and years and years, would eventually die, fade away into obscurity by Hawking radiation, which is something I have to talk about. This physicist, Stephen Hawking, made this cool thing where it pretty much makes black holes not immortal anymore. Now, you know, there's two particles that spawn in. Regular particle, matter, and antimatter. Those two usually collide together. And annihilate each other because they're both equal mass, and annihilate each other out of existence, leaving nothing behind except for some energy. With a black hole's near it, though, one of those particles goes into the black hole, and the other one leaves. He assumed that the other one was radiation. And that one takes a small bit of energy away from the black hole with it. And so, when that happens, an infinitely small amount of mass and energy from the black hole is ripped away from it. This happens over a really, really long period of time. A really, really long period of time. I don't have any props. I'm probably gonna get some soon. Not gonna do that. Might be too loud. Over billions, over years. I mean, like possibly sextillions years, but you're like a really long time. Black holes will start to evaporate and stuff, which would be really interesting. Well, not interesting. It'd be horrifying actually for the universe. Sorry, I'm yapping so much. Well, why am I sorry? No, this is my channel. I'm supposed to be happy. I'm supposed to be entertaining you people. You guys. In fact, leave some suggestions, ideas down below. I already have some, but I welcome more. I do welcome more. I take suggestions. That's, like I said before, it's your channel. I'm just the host. Simple as that. You own this channel. This is your channel. I'm here to entertain you. Either from a horrible work day, horrible day at school, or just want to relax and fall asleep to me. Whispering in your ear, or talking soft-spokenly, or maybe regular voice sometimes, very consistent. You want to listen to that? I'm here for it. Don't know why I got here randomly. Okay, let's start. Back to the universe decaying. After an unimaginable amount of time, these black holes shrink. And as they shrink, hockey radiation gets stronger. Don't know how that works. I'm pretty sure the smaller it is, the less surface area it has. But I mean, hey, I trust this guy with degree, like really big degree, over my own. Teenage brand right here. Who actually researched a lot about the subject. Yeah, I'm really into subject. They will eventually shrink down to smaller than an atom. And then explode with a whole load of a lot of energy. I think probably bigger than a supernova, maybe like probably bigger than a kilonova. I think at least a million times stronger than the Mamba. I think it was actually all bombs together. I don't know, but it big. And as these black holes start to explode over and over and over again, it bathes the universe in the last light and heat and excitement you will ever see in it the rest of its cold, boring, miserable, unchanging life. Eventually, what's left from the universe after an unimaginable amount of time we can't even quantify, can't imagine, or even think about, because we wouldn't even be able to tangentialize it or think about it because it's so big. I forgot the word. There'd be nothing but photons that slowly cool to the same temperature as the universe. Nothing else changes. Time becomes as meaningless as the laws of the universe do then. Well, will still not be meaningless, but it'd be pretty damn useless. But yeah, time would become useless. An unchanging, uncaring, cold universe of infinite darkness. But it's also another possibility that civilizations could have somehow escaped from that universe. Multiverse theory, where there's multiple universes with their own unique sets of rules, laws of physics. I mean, a species could have grabbed an atom smasher, smashed into a point with an ungodly amount of energy to create a baby universe. Or we create artificial universes that way too, simulated ones, or just dip out of this one. But again, the three main universes, I forgot to mention that. One, if the dark energy stays unchanging and still moves, it would stay moving like that forever. We get the ending I said. Most people agree what happened, both physicists anyways. The second one, it's way more violent. At least it was anyways. Which both of them are pretty equally violent. The Big Rip. The last one was called the Heat Death, by far the longest lasting one. In the Big Rip, dark energy actually becomes more powerful and stronger over time, which end up leaving the universe to start being apart. Because dark energy, being a molecular bond and stuff, would start to overcome it. Like, say, galaxies, for example. The pressure between them would be too great on it, and it would be ripped apart. Individual star systems, the dark matter growing in between the orbits of the star and the planets, and between the planets and planets too, or the moons, would be so great that it would force them away from each other. The star would be the dark energy between the rock, liquid, and the plasma and gas in the planets and stars would be so greater than gravity, those would be ripped apart. And eventually asteroids would face the same fate. Human-sized objects would face the same thing. Hell, even subatomic particles, like protons and neutrons, and possibly even quarks, would have the energy so great down there, even too, they would be ripped apart too. Which would leave the universe full of protons, neutrons, electrons that never ever see each other because dark energy prevents it. Oh, and also, I'm pretty sure space-time would actually be ripped apart too, eventually, so very nice. Very good. But then we get to my favorite, which is actually two combined ones. The Big Crunch and the Big Bounce. The Big Crunch is where the universe is where dark energy becomes weaker over time, which would lead gravity to slowly squeeze everything together as the dark energy weakens. As stuff gets closer and closer, the universe actually gets hotter and hotter. Galaxies start to merge together. Star systems get close together. Everything gets close together. Until it gets so hot that even the stars get boiled away. Yeah, the smaller your universe is, the hotter it is. I don't know what happened there. Oh God, no. Oh no. A lot of times that's the first time that happened to me on camera. Great, right? Anyways, let's just move on. It would get crushed into an infinitely small point. Infinitely small. And we say like that on this big bounce. And with that infinitely small point, booms again into another big bang. Beautiful, but terrifying to think that nothing is forever. Nothing. At this point, humanity would most likely not even be a thought anymore. So what I say to you, people that are either laying in bed, sitting in a chair, driving to work, back from work, school, back, I don't know, I don't care, but I care about y'all, so I mean, I care about it. Anyways, remember, life is too short to give up, because guess what? In the time frame between the Big Bang and the death of the universe, and it becoming a lifeless void of nothingness, life would only be able to exist for 1/1000th of the lifetime that will only be able to long. Like, imagine the universe right here. Percentage-wise, here, death. Here, beginning. Life would only be able to exist for 1/1000th of a billion billionth of the percent of the universe's lifetime. Might be an exaggeration, I'm not sure, but cherish your life. You may be going through some stuff right now. Remember, there is always someone out there who cares about you. Always someone out there. And to never, ever, and I mean ever, give up on your dreams. because us humans have something no other animal has. Persistence, determination. Us an unbending resolve. Well, I guess it's more than multiple things. I think my sailors have that. Who knows, but all I know is people who climbed Mount Everest didn't give up, did they? People who went to the moon didn't give up, did they? The people who discovered fission didn't give up, did they? They never did, and they achieved something great. So if you're on a weight loss journey and feeling like you can't do it, you can. Easily. I mean, I'm on one right now, and I lost a lot of weight. I'm very proud of it. I'm very proud. I mean, this is actually kind of, this is actually big on me now. It used to not be big on me at all. It used to fit me. So yeah, remember, and I mean always remember, you're cherished. And whether you think you have no one there, or someone else there, or no one there, someone is always there for you. If you believe in religion, then there's a God up there. If you don't believe in religion, then I guess there's mites on your skin who depend on you to live. Eyelash mites depend on you to live. Your body who depends on you to live. Your cells that depend on you to live. The bacteria in your gut that want you to live so that they can survive. They all rely on you for survival. You want to deprive those little guys of... Oh. That probably made it worse. It probably made depression worse. Oof, sorry if I did. But always remember, don't give up on life. Don't know why I totally turned this into this. Oh god, I got sidetracked significantly sidetracked. I did not mean to do it. I apologize greatly. I still believe in you though. But yeah, that will conclude an episode of Rock ASMR. I hope you enjoyed this episode, and remember, always cherish yourself, no matter what. I hope that wasn't there the entire time. Remember, cherish yourself no matter what. Don't let others use you for their own gain. Believe in yourself. Auf Wiedersehen. Let's say, if it's a morning, good morning, night, good night, and auf Wiedersehen.